Assalamu alaikum viewers. Today our topic is Tanaka and Jhonston analysis, which is one of the mixed dentition analysis. And other analysis in mixed dentition like radiographic method, Mayer's analysis. But today we will discuss in detail about Tanaka and Jhonston analysis. Before its detail, come to the mixed dentition analysis. What is mixed dentition analysis and for which purpose we do mixed dentition analysis? Actually, when our all deciduous or primary teeth, when replaced by successor permanent teeth, in the result, either there will be spacing or crowding. Now, to estimate the spacing or crowding, we use mixed dentition analysis. The mixed dentition analysis helps to estimate the amount of spacing or crowding which would exist for the patient if all the primary teeth were replaced by their successor permanent teeth. Now come to the Tanaka and Jhonston analysis. In Tanaka and Jhonston analysis, first we should remember some important points. First, why we do Tanaka and Jhonston analysis? By help of Tanaka and Jhonston analysis, we determine the space required per mandibular and maxillary incisor, means central and lateral, and canine and premolar. Now, during mixed dentition, the permanent incisor are erupted, but canine and premolar are unerupted. Now, what we do to determine the space? First, we take the mesiodistal width of mandibular incisors. Then, with the help of formula, we determine the mesiodistal width of unerupted canine and premolar. Then we add the mesiodistal width of mandibular incisor plus the unerupted mesiodistal width of canine and premolar. In the result, we will get the space required for mandibular and maxillary and maxillary incisor, premolar and canine space required. Now, why we take the mesiodistal width of mandibular incisor? Why not maxillary? Because maxillary incisor size vary. Like central incisor size is greater than lateral incisor, but in mandibular incisor, both central and lateral incisor size almost equal. And next thing is, in formula we add 10.5 constant value in to determine the mesiodistal width of canine and premolar. We add 10.5 per mandibular, and we add constant value of 11 per maxillary, because in maxillary there is more space required. Now come to the detail of Tanaka and Jhonston. We measure mesiodistal width of mandibular incisors, not maxillary, as their size vary. Now, to determine the mesiodistal width of canine and premolar, we sum the mesiodistal width of mandibular incisor and divide by 2. Per mandibular, canine and premolar mesiodistal width, we add a constant value of 10.5. Per maxillary, canine and premolar mesiodistal width, we add a constant value of 11. Now come to the per mandibular. If mesiodistal width of lower incisor is 22 mm, remember this per Tanaka and Jhonston we take value in millimeter. If mesiodistal width of lower incisor is 22 mm, now we divide the 22 mm by 2. In the result, there will be 11 mm. Per lower unerupted premolar and canine, we add 10.5 constant value in 11. In the result, there will be 11 plus 10.5. In the result, there will be 21.5 mm. This is width of a single side. This is mesodistal width of unerupted canine and premolar of single side. So for both sides we multiply by 2. When we multiply 21.5 with 2, in the result there will be 43. Mean 43 is the mesodistal width of unerupted premolar and canine on both sides of mandible. Now we add width of lower incisor and unerupted canine and premolar. The width of lower incisor was 22, but the mesodistal width of unerupted canine and premolar was 43. 43 plus 22 is equal to 65 mm. Now the space required in lower arch per incisor, canine and premolar is 65 mm. Now this is the space required per lower incisor, canine and premolar. This is Tanaka and Jhonston per mandibular incisor, canine and premolar. Now come per maxillary. Per maxillary unerupted canine and premolar. Now here we again per maxillary we take the mesodistal width of lower incisor. Why? Because we already studied per maxillary mesodistal width of incisor, central and lateral incisor sizes vary. Now here we will put the mesodistal width of mandibular incisor per molar correction, for example 22 mm, same. Now divide with 2, in the result there will be 11, and also add 11. The per maxilla the constant value is 11. Now add 11 plus 11, there will be 22 mm per one side, and per both sides multiply with 2, in the result there will be 44 mm. Now here this is the 44 mm mesodistal width of a unerupted canine premolar on both sides of maxilla. Now some both side of maxillary incisor value. Now we will take because we determine the space required per maxillary, central incisor, lateral incisor, canine and premolar. Now we have a value of 44 mm per mesodistal width of canine and premolar, unerupted canine and premolar. Now we will take the mesodistal width of maxillary incisor, and then this value is 38 mm, and we add 38 mm in the plus mesodistal width of unerupted canine and premolar, which is 44 mm. 44 plus 38 is 82 mm, mean the space required per maxillary, central incisor, lateral incisor, canine and premolar is 82 mm. This is the space required in maxillary arch. Mean the space required in maxillary arch is more, which is 82 mm, and the space required per mandibular arch is less, which is 65 mm. Now with the help of Tanaka and Jhonston, we determine the space required in mandibular arch per central incisor, lateral incisor, canine and premolar, and also we determine the space required per central incisor, lateral incisor, canine and premolar in maxillary arch. This is all about Tanaka and Jhonston analysis. Now if you like my video, press the like button and share this video with your friends. If you're new to my channel, subscribe my channel by pressing the red subscribe button, and also press the bell icon in order to receive my each new video notification. For watching my videos, I am very thankful to you. Thank you very much.